Hi everyone, this lesson is for Geometry, CPM, Chapter 2, review for our chapter test that's coming up. So let's get started. We have definitely a lot of learning targets that we've covered for this chapter. It is expected that you review each and every one of those, and just make sure that you have the vocabulary, you have practice problems that you've finished, etc., to just practice for, questions that might pop up on the test. So we're going to start off with a parallel line types of angles review. And your job is to basically say, are the angles going to be congruent? If they are, what kind of angles are they? And if you have a name for those, and then also if they're not congruent, then they possibly might be supplementary. So for this first problem right here, we have two parallel lines cut by transversal. These two angles here, how they're both on top of the line like that on the same side, those are called corresponding angles. Right here, we have two parallel lines cut by a transversal, and these two angles are both on the interior of my parallel lines, meaning if they are on the interior and they're not on the same side, they're on alternate sides, we call those alternate interior angles, and they are congruent. Corresponding angles are congruent, yes. And alternate interior angles are also congruent. These two angles right here, you don't necessarily have to have parallel lines to have these two angles congruent. These two angles are congruent. We call these angles vertical angles. These two angles here, definitely not congruent unless my two parallel lines that are cut by a transversal are perpendicular, in which case then they would be congruent and they would be 90 degrees. However, it doesn't say that they're perpendicular, and therefore they would be supplementary and not congruent. But I do want to say, if you're ever looking at this and you're thinking that maybe, you're not sure how this would work, etc., you could always plot a value. Say, I could say this is 80 degrees here, which would make that 80 here because those are vertical angles. Let's say corresponding angles. Those are also 80. This is 80, that's 80, that's 80. But, and then this being a line, that would be 100. And so 100 plus 80, 180 supplementary angles. These two angles down here are what we call alternate exterior angles. And those angles, yes, are congruent. These two angles here are what we call supplementary because they do create a line. They make a line. We also call them a linear pair as well. And unless, like you have this example where they are perpendicular, then they are not congruent. If they were perpendicular, if these angles right here, if these two lines were perpendicular, you would have congruent angles. They would both be 90, right? So then you could say that they were equal, but it doesn't say that. So they're supplementary, as well as G, which these are, we call those same side interior angles because they're on the same side and they're inside my parallel lines. So we call those same side interior angles. And again, not congruent, but supplementary. Okay. For this problem here, we are trying to find the area of each figure. So for this problem here, I am going to just break this up straight down like that. And I know that if this whole line down here is 15 and this little part is 10, that would make this 5. And I need to find the area of both of these shapes to find the area of the whole shape. So breaking that up, I know this is 10 and that's 5. Okay, so 10 times 8, so the area of this rectangle is 80. And if that's inches, that's going to be inches squared. And then the area of this rectangle, the taller rectangle, is 12 times 5, which is 60, and that's going to be inches squared as well. And so the area of the whole shape is going to be 60 plus 80, and these are going to be inches squared. And so 60 plus 80 is 140, and that's my area. Okay. For this one right here is a right triangle, looks like, and it also, the area of a triangle, remember that anytime you have area of a triangle or parallelogram, etc., the base has to be perpendicular to the height, and I can see clearly that it is. So the area of the triangle is 1/2 my base, which is 8, times my height, which is 3. 8 times 3 is 24. 24 divided by 2 is 12. That makes 12 centimeters squared for this area. The next problem has to do with a segment that connects these 2 points. So I'm going to plot my points, and let's see what we get here. All right, we've got one point. We have 1 point that is at -4, 8. So 1, 2, 3, 4, all the way to 8. And so that's my A value. We have B, which is 1, 2, 3, 4, 5, 6. 1, 2, 3. So here's B, which is 6, 3. And it says graph the segment that connects these 2 points. Okay, so we did that. And write an equation for the line that connects the 2 points. Oh, and what's the slope? Well, the slope is going to be the rise over the run. So you can either count up and over, or you can just use the formula for the slope, which says it's the change in y divided by the change in x, or over. So the change in y would be 3 minus 8. So we're going to go 3 minus 8. Change meaning difference, right? And then the change in x's is going to be 6 minus -4. So that's 3 minus 8 is -5. 6 plus 4 is 10. So my slope is -1/2, which does make sense because it is going down right. So to come up with an equation that works for this line segment or the line, then what I would do is choose a point. So we remember our points are -4, 8, and then we have 6, 3. You just pick one point, and then we're going to use the slope. So we're going to start off putting it in point slope form. So I'm going to choose -4, 8. So remember, point slope form, you're going to go y minus 8. It's always that opposite value, is equal to my slope, which is -1/2 times x plus 4. Point slope. So now I'm going to solve for y. So I've got y equals -1/2 x. And then -1/2 times 4 is going to be -2. And then I still need to add the 8 to the other side. I get y is equal to -1/2 x plus 6. So that's slope-intercept form. It says, now I need to write an equation for a line that's parallel to AB. So any equation of any equation of a line, here's my equation right here. If lines are parallel, that just means they have the same slope, but I can actually start wherever I want. So I even could start at 0, 0, like I wrote here. So I can say an equation of a line that is parallel would be just y equals -1/2 x, with the slope, with the y-intercept being 0. And then write an equation for a line that is perpendicular. So again, perpendicular lines have opposite reciprocal slopes, right? So that means that they come straight down like that. They're going to be perpendicular. So then I would say that last problem for this one right here, I can say y equals, if my slope is equal to -1/2, I'm going to flip that over 2 over 1, right, and take the opposite sign. So it's going to be 2x, and then I'm done. I could say 2x plus 1 plus 2 plus 3, or I could just say y equals 2x, and then that's going to be perpendicular. For this problem here, we have a square. It says that the diagonal of this square, here's my diagonal, is equal to 2√6. Your job is to find the area of the square. Well, the area of a square, so the area of a square is equal to base times height, or side squared, right? Because the base and the height are the same value. So, I mean, you can say base times height, you can say side squared. Regardless, we still have to find the side, and we only know the diagonal. So in order to find one of the sides, I noticed that they're both the same value because a square has 4 congruent or 4 equal sides. So I'm going to use Pythagorean theorem, and I'm going to say x squared plus x squared. So side squared plus side squared is equal to my hypotenuse, which is the side opposite the right angle, my hypotenuse, which is 2√6 quantity squared. Now be careful with the hypotenuse. When you square a hypotenuse, right, that's actually 2√6 times 2√6. And remember, numbers get multiplied with numbers. So that's 2 times 2, which is 4. √6 times √6, which is √36, which is 6. So 4 times 6 That's 24. So on the right side, so far I've got 24. On the left side, I've got I've got x squared plus x squared, which is 2x squared. Okay, and I'm trying to isolate the x to find the x. So we are going to divide by 2. I get x squared is equal to 24 divided by 2, which is 12. And to find one side, I'm going to square root both sides. And so I get x equals the square root of 12. Now, yes, I can definitely reduce that, but I'm going to hold off on reducing that right now because I'm going to use that to find the area, because my area is one side, which is the square root of 12, quantity squared. So root 12, so this is really root 12 times root 12, which is the square root of 144, which is 12. And so basically, yeah, it didn't do me any good to, wouldn't have done me any good to reduce root 12, but just so that you know how to reduce 12, let me show you. That's going to be root 4 times root 3. Square root of 4 is 2, so that would have been 2 root 3. For this problems here, we are to find the area of both of these shapes. And so what we need to know is that the area equals 1/2 base times height for a triangle where my base is perpendicular to my height. So that means that this value down below here is actually my base. So that looks like, let's see here, 1, 2, 3, 4, 5. That looks like it's 5 this way. 1, 2, 3, 4, oh, 5 that way as well. So it looks like my base is 10. So the area of the triangle is going to be 1/2 my base, which is 10, times my height. And it does look like I can actually figure that out. And it looks like my height is 8. So in finding the area, you would just say half of one of these. Now you can either say half of 80, which is 40. And that's, I don't have any units, so we're going to just call it unit squared. Or you could take half of one of the values, right, and then go 5 times 8. Just make sure that you're not taking half of each, right? You're not taking half of 10 and half of 8. Don't do that. Okay, so now for this problem here, this is a parallelogram. Parallelograms have, in order to find the area, it is base times height. However, it is base perpendicular to height. So you do have to know what the height is, and it has to be perpendicular to the base. So here we go with our base. We've got, looks like we got 1, 2, 3 on the left. We have 1, 2, 3, 4, 5 on the right. So that base is now 8. So the area is going to be base times height. So 8 times my height. That's just this height, and that's the same distance all the way around. It looks like it's 1, 2, 3, 4, 5. And so my height is 5. So 8 times 5 is 40 units squared. Right on. Okay, here we go. Find the area of an equilateral triangle that has a length of 6. Well, that means that if it's equilateral, all the sides are the same measure. Also, in order to find the area of a triangle, it is 1/2 base times height, where the base is perpendicular to the height. Has to be. So it's going to be 1/2 my base. I already know the base is 6. They gave me that information. But I do need to find the height. Now, I do know, and this only works with isosceles or equilateral triangles, that when my altitude, which is my height, drops down, it is perpendicular to the base, and it does cut my base into 2 equal parts. So this value is 3, and then that means my height, I don't know. Now, I have an option here because I know this is an equilateral triangle. And if it's equilateral triangle, that means that each of the angles is 60 degrees, right? So that is 60, that's 90, and oh my goodness, there's 30. That's a 30, 60, 90 triangle. Remember? Opposite, so remember what we talked about in class the other day. Opposite the 30-degree angle is A. Opposite the 60 is A root 3. And opposite the 90 is 2A. So if opposite the 30 is A, that means 3 is A. Then opposite the 60 is A root 3. So that would be equal to 3 root 3. So I know my height is 3 root 3. And just a note, I get that maybe you forgot how to do that part. And so if you did, I would say this. I would say this. I would say, yes, this is 3. That's x, and that's 6. I also could, yes, use the Pythagorean theorem, option B, and I could say 3 squared plus x squared is equal to 6 squared. 9 plus x squared equals 36. X squared equals, subtract 9, what is that, 27. Take the square root of both sides, and I get x equals the square root of 9 times the square root of 3, which is, of course, 3 root 3. So, same thing. Now, lastly, we need to simplify. 2 divides into 6 3 times once here. And I have 1 times 3, which is 3. 3 times 3, which is 9. And so we have 9 root 3 units squared is going to be the area for this triangle, equilateral triangle. The next question says, the measure of an angle is this, and the measure of its complement is that. So complementary angles are 2 angles that add up to be 90 degrees. So I'm going to draw a 90-degree angle because this actually helps when I'm solving a problem. I know that one of them, and it didn't specify, is at 5x plus 14. The other one is 3x minus 20. But I do know that when I do add these 2 equations up, so 5x plus 14 plus 3x minus 20 does equal 90 degrees. So 5 and 3 is 8x. 14 minus 20 is negative 6, and that equals 90. 8x equals 96. Divide by 8, go on the side, 96 divided by 8. 8 goes into 9 once, 1 remaining, 12. 12 is my answer. That's x. Now, that if that's all they ask me, x is not my angle. They just asked me to find x. However, I will be asking you to find an angle, and that means that you need to take x, which is 12, and plug it back into the equation in order to find the actual angles, right? So, for example, 3 times 12, right, if I plugged in 12 here, 3 times 12 is 36, okay? And if you have 36 and you subtract 20, right, you have 16, meaning this angle is 16. And also, 16 plus what is 90? So if I take 90 and I subtract 16, I'm going to get this angle to be 74 degrees. So if they're just asking me for x, we got that. However, if they ask me to find the angle, I do need to plug it back into the equation. The diagonal of a rectangle is 2 root 3. So we've got this diagonal we know is 2 root 3. Now, the thing about a rectangle is that opposite sides are congruent, and that's congruent to that, but it is a right triangle, okay? The height is root 5. Your job is to find the area. Well, the area is base times height. So the area of a rectangle is equal to the base. Oh, no, I don't have the base, but I do have the height, which is square root of 5. So in order to find the base right here, which I don't know, this is my base right here, I'm going to use the Pythagorean theorem, and I'm going to just call that, I don't know, and we're going to go x squared plus the square root of 5 squared is equal to 2 root 3 squared. And so we've got x squared plus the square root of 5 times the square root of 5 is square root of 25, which is 5. The roots, when you square a square root, remember we talked about this. If I am squaring a square root, that's saying this. It's saying 5, because a root is a half power, right? That's the square root. This is the square root of 5. That is the same thing. And so when I square that, what's really happening is these 2's are canceling, right? And so then I just get 5, which is that what I got. Okay, so then we've got 2 root 3 times 2 root 3. So 2 times 2, remember, numbers get multiplied with numbers, roots get multiplied with roots. So 2 times 2 is 4. Root 3 times root 3 is the square root of 9. Well, the square root of 9 is 3, so that's 4 times 3. So we've got x squared, what do we have? Plus 5 is equal to 12. X squared is equal to 7. We're going to square root both sides, and so I've got x is equal to the square root of 7. Now, I know the instinct is to circle that and move on to the next problem. However, That's not what they asked me. They asked me to find the area, and all I just did was I found the length of one side, right? Square root of 7. So remember, that's my base, and so that needs to go in here. So realistically, what I'm doing now is I'm saying the area of my rectangle is base, which is square root of 7, times the height, which is the square root of 5. So the square root of 7 times the square root of 5, 5 times 7 is 35. And this is units squared. Area is units times units, so that's units squared. The next type of problem that you might see on the test is something like this, where I ask you to find the value of x, of course, but also I ask you to find the value of a. I do recognize that these are vertical angles, and vertical angles are congruent, which means that I can say 4x minus 7 is equal to 3x plus 12 because they're congruent. They're equal, they're the same, right? I would subtract 3x, I get x. I'm going to add 7, I get x equals 19. I'm going to plug my value because, yes, I found x is 19. But I also need to find a. And a is on the, I can use this and this, or I can use this and this. Either way is completely fine. So I'm just going to plug in 19 into this angle here, all right? So in order to do that, I'm going to go 3 times 19 and then add 12. Okay, so 3 times 19 is 57. And so 57 add 12 is going to be 69. A is 69. No, that's not true. A is, that's just this angle. So let me erase that because I'm just jumping the gun here. This angle right here is 69, which means that 180 minus 69 is 111. And so this angle right here is 111. And that is my A. Okay, almost made a mistake. Uh-oh. Okay, so here we go. What are the values for each variable? So, right, don't you love these variables? So we've got t, and so we've got t. Let me put these down. Looks like we have h, and then we've got O, and then R. Oh my goodness, who's our favorite Marvel character? Okay, so we have t. Now, what I'm looking at is this. I've got two parallel lines, cut by transversal, cut by transversal. Now, notice a couple of things. These are parallel. That's 90, which means that has to be 90, which means that this has to be 90, which means that if that's 20, then that must be 70 because 70 and 20 is 90. So T is 70. Now, it also means that H has to be 90, and O is opposite this angle, which are vertical angles. So O is 20 degrees. All right, and what else do we know? We know that's 20, and that must be 70. Yep, okay. And then I know that this angle and then this angle, they're not congruent, right? But they are supplementary, which means that this must be 110. And so R is 110. So not almost done because I got to make sure that I answered the question which said, what is T plus R? So T was, it looks like T was 70. So we would go 70 plus R, which is 110. 70 plus 110 in this instance is 180 degrees. Done. Okay. And the next problem says graph the system of equations. So remember how to graph. We have the graphing that we use in slope-intercept form is y equals mx plus b. Okay, so we can graph. When it says graph the system, when they're asking me to graph two lines, what they're really asking me to do is to actually find the point where the two graphs cross. That's when you're graphing a system, okay, or trying to find the intersection point. And so graphing that, I'm going to start off at 4 because that you always start off at the y-intercept. So we got 1, 2, 3, 4 right here. The slope is negative 2 over 1, which means drop down to go over 1, drop down to go over 1, this is a solid line. And so there's my line for the first equation, which is y equals negative 2x plus 4. Now, the second equation is y equals 3x minus 1. We're going to start at negative 1. My slope is up 3 over 1. So 1, 2, 3, over 1. And so that means that it looks like I really just crossed right on the money, right there on the corner. And this is the graph for y equals 3x minus 1. It is not enough to graph both of the lines. You're going to be turning in your work. You have to not only graph the lines if I ask you to solve by graphing, but you also have to find what's called the intersection point right there. Where are they crossing? That's the break-even point. And so that looks like it's 1, 2. Yeah, that point is 1, 2. And so that's my intersection point. But, to be honest, it's a little tricky in there. I would plug my values in to make sure that I did it right? So remember, this is x and that's y. You can plug it back into either or both of the equations. So y is 2. So we've got 2 equals 3 times x minus 1. So 3 minus 1 is 2. 2 equals 2. Check. Sounds like we got the right answer. I will tell you something else, though. Another way of actually solving this equation, not by graphing method, but if you were to look at this is also what we call substitution method. See, this is y and that's y. Well, y is going to equal y. So if y is equal to itself, then negative 2x plus 4 is going to equal 3x minus 1, right? Add 2x to both sides, I get 5x. Add 1 to both sides, and I get 5x equals 5. Divide by 5, I get x equals 1, which we have. And then I would just go back up and plug 1 back into my equation to get the 2 or the other value. So just heads up, multiple ways of solving for sure. This question is saying, hey, we've got an equilateral triangle. By the way, equilateral means all sides are congruent. And if that's the case, all the angles are congruent. And if all the angles are congruent, right, we know that all the angles then are 60 degrees. And it means that if I decide to drop down an altitude, it's going to cut that in half. And therefore, this now is not 60 degrees. This angle up top now is 30. Okay? Anyway, it said the length of each of the sides have a length of 5. And it sits on the x-axis at the origin, and it's translated to this. Well, this isn't an area problem at all. This is a translation problem. And if you remember, that was last chapter. Okay, so we are going to, where is the vertice located that was at the origin? Okay, so we're going to say that is what they're looking for. I'm going to draw this like this and just draw and move everything 5. So, or actually not 5, but move it how they want to go. They want to go plus 4 to the right. So if it's x, this is x, right? So if they want to go plus 4, we're going to the right. So this right here means go to the right on the x-axis, okay? This one right here says minus 6. So x on the y-axis, it could go up or down. But because it says y minus 6, we're going to go down on the y-axis. So we're going to go, let me say, 4 to the right. So 1, 2, 3, 4. And then we're going to go down 6. 1, 2, 3, 4, 5, 6. So now I'm here. Where am I? I'm at 4, negative 6. That's where I'm at, right there in the corner. All right, so I think that was the only question they asked you. Where were you? This translated to that over 4, right? Over 4, down 6. So over 4, down 6, the point where we're at is actually 4, negative 6. Okay. That was a question that actually, I just want to go back real quick. That was a question that actually had way more information in it than I needed to solve this, right? I mean, because we were talking about sides of length 5. We didn't need to know that. We were talking about this being an equilateral triangle. We didn't need to know that either. We didn't need to know that the angles were 60 degrees. So they were just having us move something, right? And so that was all we had to do. For this problem, it says the diagonals of a rectangle are 8 units long. Yeah. And for a rectangle, by the way, diagonals are congruent. And okay, so we have this right angle right here, and base for this rectangle, diagonals are 8, and they intersect. At a 120-degree angle. That is super cool. Okay, so that means that these two angles. Okay, so I'm going to lose the right angle here because that's not relating to what I need to do. So we are going to go like this. We know that they're right. It says they intersect at a 120-degree angle, which then that's 120 down here, which means this is super neat. If I split this up, now I've got a 60-degree angle, and this is going to be perpendicular, 30, 60, 90. Now, we knew that this diagonal was, what was it, 8? And we know that they're congruent, so that makes this 4, this 4, that 4, that 4. Okay, so realistically, I'm going to redraw this, okay, like this. This is what I have. I got a 60-degree angle here, and a 31 here, and a 4. Our job is to... What is our job? To find the area of the rectangle. The area of a rectangle is equal to base times height. I don't have either one, but I do have a bunch of information, so we can do this. 30, 60, 90 right triangle. Remember, across from the right angle is equal to 2a. Across from the 30-degree angle is a, and across from the 60 is a root 3. So if across from the 90 is 2a, that means that a divided by 2, right, is 2. 4 divided by 2 is 2. So that means this is 2. And then this is 2 root 3. So putting all of that down, I know that this here is 2 root 3. I know this is 2, which means that's 2, which means my height of my rectangle is 4. Perfect. Now for my base, I know that this is 2 root 3 and this is 2 root 3. And when you're adding 2 root 3 plus 2 root 3, that's going to be 4 root 3. So the base, okay, altogether is 4 root 3. That's the base. So all I have to do is go base times height. So 4 root 3 times 4. And yes, you do actually need to multiply, right, also. So what this means is that numbers get multiplied with numbers. And so that's 16, and then we have root 3, and it doesn't, I'm just in units, so this is area. We are talking units squared. Cool, I like that one. Solve the system of equations. So this is another system. We already graphed one system of equations. Again, the whole purpose for solving a system of equations is to actually find the intersection point. So we have two equations. Yes, I can graph them. My other option is, there's the graphing method you can do. You can also do what's called elimination. And you can also do substitution, where you solve for one of the variables and plug it into the other equation. So, I'm up for doing both if you want. Let's see. I'm not going to eliminate my x's. If I'm going to do this by, let's say, elimination, what I would do for this one is I would, see I've got a y and a y. I would actually subtract the top equation from the bottom equation, the bottom from the top. And so 2 minus negative 3x, like that, right? So what's 2 minus negative 3? That's plus, so that's 5. So we've got 5x, and then y minus y, 0, that's gone. We've eliminated it, goodbye. And then the bottom one is 4 minus negative 1. So 4 minus negative 1, which is 5. So that means x equals 1. Okay, right on. We've got x. Plug it back into one of the equations. I'm going to go back. 2x plus y equals 4. So I'm going to plug this in here. So 2 times 1 plus y equals 4. So I get 2 plus y. I'm going to subtract 2 from both sides. So that means y equals 4 minus 2, which is 2. And you don't, in this kind of a problem, the purpose is yes, it's to find x and y, but the purpose is also for you to recognize that the intersection between these two lines is a point. And we write a point like this. And so that's ultimately where I'm going with this. You make sure that you can do that. Okay. So that's elimination. I'm just gonna like really quick do this for substitution. If I was going to solve this by substitution, I would probably just solve one of these equations for y. So I'm going to do that up here. I'm going to go y is equal to negative 2x plus 4. What I did was I took this 2x and moved it to the other side of the equation. And I'm going to say, hey, that's y. Why is that? And then I'm going to take that value, and plug it into the other equation, which is negative 3x plus y equals negative 1. This is y. I'm going to put that there. That's what, just like you're taking the y out and substituting it back in, right? So we've got negative 3x and then plus y. That's y. So we're going to go plus negative 2x plus 4 is equal to negative 1. So negative 3 and negative 2 is negative 5x. Add 4 is negative 1. I'm going to subtract 4 from both sides. I get negative 5x equals negative 5, x equals 1, positive 1. Plug it back into the equation here, and you get negative 2 times 1 is negative 2, add 4, which is 2. And so then I get my point again. So definitely just alternate ways of solving an equation, okay? This question says solve for x, so just x, no angles. You can actually do this a couple ways. I'm just going to be honest with you. I know that the sum of the angles of a triangle add up to be 180 degrees. So I can actually go 180 minus 49 minus 34. And I know that this angle here is got to equal 97. And so realistically, the easiest course of action is just to say that equals 97. 4x equals 100 because I add 3 to both sides. X is equal to 25. Found x. Except for, I know that the actual way that they want you to do this, because there's going to be a problem like this on the test, like on every one of these questions. But what you need to understand, this right here is what we call the exterior remote angle theorem. I think that's triangle exterior remote angle theorem, which means that whatever this angle is here, let's say it's 100, it equals to the sum of the two remote interior angles. So if that was 20, right, that would have to be 80 because they have to all add up to be 100. So realistically, what they're expecting you to do is to say that angle right there, which is 3x plus 56, is equal to the sum of the two remote interior angles. So they're saying that that is going to equal 34 plus 4x minus 3. Yeah. And, okay, what do we know? We know that 3x add 56 equals 4x, and then plus 31, right? Because 34 minus 3 is 31. If I subtract 31 from both sides, so minus 31, I get 25. And if I subtract 3x from both sides, I get x. And then I get x equals 25 again, which is what I had in the first place. So I guess if I were going to do this on the actual test, I would probably not give you this angle here, because then you would have to know that this angle here is equal to that plus that. Glad I caught that. Okay. R is parallel to S. Okay, so that's super fun. Now we have all these super fun things that happen. If angle 1 is 105, then I'm just going to put all these values in, right? I know that, what am I trying to find? 5 and 7. Okay, so this is 105, that's 105. Okay, these are vertical angles. This is 105 because these are alternate interior angles. And so angle 5 is 105 because those are congruent. Alternate interior angles are congruent. And then in order to find angle 7, I'm going to take 180 degrees and subtract 105, right? And that's just 75 degrees, 75. So that means that the measure of angle 7 is 75 degrees. Okay. Then it says solve for x. So now I've got different values, but the same picture. So I wonder if I can make, no, can't do that. Okay, so the measure of angle 2 is 70. All right. And then it says the measure of angle 8, which is way down here, is 6x minus 2. Solve for x. So what I do know is this is 70 here, because those are alternate interior angles, right? And I do also know that these angles, or these two angles right here, right, add up to be 180. They're supplementary. So I can go 70 plus 6x minus 2 is equal to 180. And that makes 6x. So 70 minus 2 is 68, right? Subtract 68 from both sides. So 180 minus 68, what is that? Okay, I guess I could not be lazy. 62 is 118. So 6x equals 118. And then now I'm going to divide that by 6. Ew, that didn't come out right. Did I add that right? 70 minus, let's see, 70 minus 2 is 68, right? Subtract 68. Let me do that again. 180 minus 68 is 112. And 112, not 118. There we go. That's where I messed up. Yeah, always check your answers, right? You would think using the calculator I'd get it right. Okay, here we go. 112 is equal to 6x. And divide 112, let's see, divide that by 6, and I get the same answer. I don't get the same answer, but I get a fraction. So it looks like I'm going to get a fraction. So what is that? 112 divided by 6. As a fraction, I'm going to go to math and say, hey, I want that as my lowest fraction. So what's that? 56 divided by 3. All right. I'm going to do that one more time. I want to make sure I got the right answer. So I'm going to do this one more time, just for fun, right? We know, let's see, what do we know? X, number 2, is 70, so that's 70, and that's 110. And that's 110, so I can just go 6x minus 2 equals 110. 6x equals 112, and 112 divided by 6 is that. Okay, we're good. All right, next problem, we're going to do that one more time, but a different question. So this question is saying the measure of angle 3 is 8y minus 40, and the measure of angle 8 is 2y plus 20. Well, 3 and 8 are corresponding angles, okay? Corresponding angles are congruent. So that means that I can set those two equal to each other. So 8y minus 40 is equal to 2y plus 20. And I'm going to subtract 2y, I get 6y. I'm going to add 40, and so I'm going to get 60. And so y is equal to 10. So we have y. What am I looking for? Y. Okay, we're good. So the only thing that I would just say is that we can find x and y's and all of that. But, you know, I would just make sure that you can find the angles too, right? Because like if I plug this in here, that's 2 times 10, which is 20. Plus 20 is 40. So I know that angle 8 is 40. I mean, they definitely might ask you that too. And then I could have plugged it in here. 8 times 10 is 80, but 80 minus 40 is still 40. So I got the right answer. We are going to be tested on conditionals. So for example, if today is Monday, then we have a test. Today's Tuesday. What can you infer? Well, we don't have a test because it's not Monday, right? Or you could infer that you already took the test because it was Monday and now it's Tuesday. Okay, so you can infer things with conditionals. If today is Tuesday, then tomorrow is Wednesday. What's the hypothesis? So it's important to know the difference between the hypothesis and the conclusion. It's also important to know what the actual hypothesis contains. And so I want to be very specific. If it says what's the hypothesis, hypotheses do not have the word if in them. So the hypothesis is not if, it's just today's Tuesday. And then the conclusion doesn't have the word then in it. That would say the conclusion would be tomorrow is Wednesday. Okay, so just keep that in your head. The hypothesis does not have the word if in it. The conclusion does not have the word then in it. Okay, So today is Tuesday. Yay. Okay. All right. Identify the if then. So they want you to put these in if then form. The question says all cars have wheels. So I would say if a, if if a vehicle is a car, then it has four wheels. If a vehicle has four wheels, then it's a car. If a vehicle is a car, then it has four wheels. These both are the same thing, except this one, because they have cars are first and wheels are second. Car is first, wheel is second. Okay, so this would be my equation, my conditional. Okay, this is my conditional because it's if a vehicle is a car, then it has four wheels. However, we also have something called a converse, and we talked about that in class the other day, where we take our conditional, which is our hypothesis and our conclusion, and we flip places. So then what we have is what's called the converse. All right. And so this one is actually the converse, because that took my hypothesis and my conclusion and it flipped it. This one, if the vehicle is not a car, then it does not have four wheels. This one is called the inverse. That's what that's called. Because it's saying, because we started off saying if a vehicle is a car, then it has four wheels. If the vehicle is not a car, that's the inverse. It's the opposite. If it's not a car, then it doesn't have four wheels. So that would be the inverse. If possible, write a conclusion. If the conclusion is not possible, say no conclusion. If you have a can opener, you can open a can. Jack has a can opener. So Jack can open a can. Yes, we have a conclusion. Jack can open the can. Okay, if it rains, the baseball game will be canceled. There were 100,000 people at the game. So the game wasn't canceled, which means that it didn't rain. Conclusion. Right on. Okay. Then it says all right angles are congruent. Check. Vertical angles are congruent. Okay. There's no conclusion. So this would be a no. We don't have a conclusion. Vertical angles aren't right angles. Unless they are, right? Unless the two lines are perpendicular. Okay. Let's see. Fill in the appropriate symbol. We have 1 and 5. So we've got angle 1 and angle 5. 1 is greater than 5. Angle 1 and angle 2. 1 is the whole is bigger than the part, right? Because this is a vertical angle. That and that are congruent, but this is broken down into parts and that's a whole. So the whole is bigger than the part, right? Obviously, greater than. Let me erase this. 3 is greater than 4. Actually, 3, if this is parallel and that's parallel, then 3 should be equal to 4. So those are equal. And lastly, we have, let's see what we got. 5 and 2. Parallel line. You know what I'm going to do, because I keep telling you guys this. Every time you see a parallel line, sort of highlight it, right? Because what this looks like to me is that we have parallel lines cut by transversal, this being my transversal. And it looks like this angle here and this angle here are congruent because, why? They're corresponding. So they are congruent. What was this supposed to say? Angle 3 and angle 4, those are equal. Oh, I should say congruent also. What's wrong with that? Okay. All right. A lot of kids get corresponding angles confused with complementary angles. Don't do that. Complementary angles are two angles that add up to be 90 degrees, where corresponding angles are congruent, and those come in with the parallel lines. Okay, now the bottom part of this is actually saying, this was the part where we were doing inequalities in triangles. So the bottom part for this, first of all, I need to find this angle here. So I'm going to take 180 degrees. I'm going to subtract 57, and I'm going to subtract 62, and that last angle is 61. Okay. Now, what we talked about when we did this section last week was this. What is the shortest segment? The shortest side is always opposite the smallest angle. Okay? Write that down if you don't remember. The shortest side, I can spell. The shortest side is opposite the smallest angle. Yeah, I did break my wrist. I am getting better at writing, but it is a process. Okay, so, okay, shortest side is opposite the smallest angle. Okay, and that means that the longest side is opposite the largest angle. Okay, so what we have here is a 57, a 61, and a 62. I'm looking for the shortest segment, which is opposite the shortest or the smallest angle. And the smallest angle is 57, which would mean BC would be my shortest side. And when we write a segment, people, it is with a little line segment above it. Okay? If I'm looking for a measurement, like the measure of angle, like if I said the length of BC is 5 centimeters, then I would do this. BC equals 5 centimeters. If I was talking about a measurement, okay? But because I'm not talking about a measurement, I'm talking about like an actual length. It's you put a little line segment above it. Okay, anyway. The next question, we've got 60, 61. This looks like it must be 59. We've got 55, 60. Oh boy, I'm going to subtract. 180 minus 62 minus 55 is 60. Okay, now this is a trick question. Actually, I've seen this on the SAT, like different numbers and all of that kind of stuff, but you should know this. The smallest side is opposite the smallest angle. But when it looks like this, and the smallest angle is here at 55, right? That make that the smallest side. However, this is not the smallest angle in that triangle, which means that negates that. That's out. It's gone. It's out of the running. And now you go to the next smallest angle, which is 59, which if that's the case, that means that this line here, I think that says DG is now my smallest side. That is such a trick question. Okay, but that is it. Okay. The next one here says says this is 31 and that's 30. So they're definitely not congruent. We're trying to find the shortest segment. Well, the shortest segment is going to be opposite the smallest angle. So if that's the smallest angle, which is 31, and I know these two angles are congruent, right? I know that these two angles are congruent because they're opposite congruent sides. Okay? So we now know that, what do we know? What are we trying to find? Shortest segment. Well, the smallest angle is 30. So the shortest segment is that, JK. All right. Cool. And getting through this, here we go. We know this is a proportion. And the way you solve that is to do two things at a time. That equals that, that equals that. I can cross multiply. Do not cross multiply these two because one's a y and one's an x. And that's, you would need two equations. But we don't need that. Because actually, I can even say that equals that. Actually, let's do that. We know that 3/4 is equal to 11 over 3y. So let's find y. Cross multiply. 9y equals 44. Y is equal to 44 over 9. You're done. That's y. Then to find x, get rid of that. I've got one equation, one. So I can cross multiply on that. And so I'm going to go 3 times 7. I'm going to need more room here. 3 times 7, that's 21, is equal to this times this. So 4 times 2x minus 1. 21 equals 8x minus 4, add 4. 8x equals 25, x equals 25 divided by 8, and you're done. This again, this is the same problem. This is a really important problem. I'm so glad I've got two of these. I think they're different. I'd like to say they're different. Let me make this bigger so you can see. Okay, I think that, okay, 59, 61, right, 60, 60, 60. So this would be 61 degrees. 62, 180 minus 61 minus 62 is 57. Again, I mean, this is like really important. Smallest angle is opposite the smallest side. 57 is my smallest angle in this triangle. Therefore, BD would be my smallest side unless this angle is not the smallest angle in this triangle. And it's not. So again, this is negated, out of the running. And then we go to the next smallest side or smallest angle, which is 59, which then means that CD would be my smallest or my shortest side. Okay, so just, that is really important, you guys. Okay, so wrapping up almost. These are parallel. We're trying to figure out if they're parallel by making these congruent. If they were congruent, then 3x plus 10 would equal 5x minus 10, right? Subtract 3x, I get 2x. Add 10, I get 20. X equals 10. So find the value of x. That makes that, oh, we found x. And of course, if I want to find the angle, plug it in, we'd get 50 minus 10, which is 40. And so these angles would be 40 degrees. I love this pumpkin stuff, right? Yes, I look hard to find stuff for you guys. Okay, lastly, we've got parallel lines here. If these were parallel, then these two angles would add up to be supplementary, right? So that means that 6x plus 5x plus 15 would equal their sum 180 degrees, which would make that 11x plus 15 equals 180. I'm going to subtract 15, right? 180 minus 15, 165, and I've got 11x is equal to 165. Oh yeah, divide by 11, and we get 15. So now we have x equals 15. And I mean, yes, I'm just looking for x, but at the same time, you need to make sure that you can plug these values back in, right? And 15 times 6, look at that, is 90. Okay, so yeah, I could have set that equal to 90 back then, but we didn't know it was perpendicular, right? Just didn't know. Find the area of this trapezoid. We have a trapezoid, looks like this. The base lengths are 6 and 12. The legs are 5. Oh, no. The area of the trapezoid is written as height divided by 2 times the sum of the bases. The bases are 6 and 12. I don't know the height. The height, though, because this is isosceles, I can split this up like that. And so this whole thing is 12. This is 6 from here to here. 12 minus 6 is 6. That makes 3. Remember our triplets? That's a 3, 4, 5. I know the height is 4. And so that's 4 divided by 2 times 6 plus 12, which is 18. You only take half of one of them. Don't do both. So, I mean, like I could take half of 18, which is 9. 9 times 4 is 36. Remember, this is unit squared. That's the area. Just a note, if you didn't, I lost you on that part where I said this is 3, this is 5, and I already knew my height. All I did was I used the Pythagorean theorem where I said 3 squared plus height squared equals 5 squared. And so the height squared equals what? 25 minus 9, which is 16. Square root both sides. The square root of 16 is 4. So that's the same problem. Just finished, almost. If two parallel lines are cut by a transversal, then the alternate interior angles, that would be this one and this one, are always congruent. When two parallel lines are cut by a transversal, blank pairs of corresponding angles. Oh boy, oh boy. Let's look at that. Okay, corresponding angles. We got the top and the top. That's one. Bottom, bottom, two. Top, top, three. Bottom, bottom. That's four. Four pairs. Lines that don't intersect, well, they're either parallel, right? Parallel or like that, or they're skew. Remember, parallel lines, if lines are parallel or lines intersect, remember, intersecting lines have to be in a plane. No exceptions. Parallel lines, if they're parallel, they have to be in a plane. No exception. That means that you can't have one line here parallel to this line out here. That would make that skew, and that won't work. Okay. Lastly, if AB, here's AB, is parallel to CD, here's CD. Okay, they're parallel, and CD, here's CD, is parallel to EF. Okay. Well, if that, what does that mean? We know CD is parallel to EF. We know AB is parallel to CD. So that means that AB is parallel, line segment AB is parallel to line segment EF. By the way, that's the transitive property. Okay. We're done. So that was a long review. I get it. But I'm glad you stayed to the end. You will be better off for it on your test. So good luck, and thanks for watching. Oh, yeah, no homework. Right on, good.